Now we're going to multiply monomials. So when we're multiplying things with exponents on them, you want to remember that we add those exponents together. So x cubed times x5 is going to be x to the 3 plus 5, which is x to the 8. And the reason we do that, think of x cubed means x times x times x, right? X to the 5th then means we're multiplying these together, x times x times x times x times x. So there's 5 of those, and then if we're doing x cubed, there's 3 of those. Well, now, if we're going to multiply that all together, there's 8 of them, so that's x to the 8th power. So x to the 7th times x to the 4 is x to the 7 plus 4, which is x to the 11th. Now, we have to remember that when we have numbers in front of these x's, you're still going to multiply your numbers just like you normally do. So the key here is to multiply the numbers and add the exponents. And remember, it has to be the same base. So you can only add, when we talk about the base, we're talking about this x here. So I can't have x cubed times n to the 5th. That's not going to be x n to the 8th or anything. You have to have the same base and add those exponents on those bases. Another thing to remember is if you just have an x, or if you have an a or b, whatever it is, and there's nothing above it. So if we have an m, remember, if it's all by itself, that's an imaginary 1 up there. So always keep that in mind. If it's by itself, that means it's just 1. So in this case, we've got 3n squared times 4n to the 4th. We're going to multiply our numbers. So that's going to be 3 times 4, which is 12. Then we're going to add the exponents on the n. So n to the 2 plus 4 is n to the 6th power. So multiply your numbers, add your exponents. Okay, so now let's try it again. Negative 3 times 5 is negative 15. And remember, it's got to be the same base or the ones that we're adding together. This a has that imaginary 1. So a squared times a is 2a to the 2 plus 1. So a cubed. And then our b's, b cubed times b to the 4th is b to the 3 plus 4. So b to the 7th power. Final answer. Okay, so again, remember, nothing in front of here, imaginary 1. So 2 times 1 is 2 times negative 3 is negative 6. You're going to multiply all of your numbers. Then, again, these a's here, they don't have an exponent, so it's imaginary 1. So there's a to the 1, a to the 1, and a squared. So a to the 1 plus 1 plus 2 is a to the 4th power. Then let's look at our b's. So b, imaginary 1, another b with imaginary 1. So 1 plus 1, and then b plus to the 5th power. So 1 plus 1 plus 5 is b to the 7th power. Okay, so hopefully you're getting the hang of that, and multiply the numbers, add your exponents. When it's a fraction, remember when we multiply fractions, it's just top times top and bottom times bottom. So let's do top times top. We've got 20 times 12, which is 240. And then x squared times x cubed, 2 plus 3, x to the 5th. And then y, imaginary 1, and y to the 5th is y to the 6th. So, my I always say just do one thing at a time. Do your numbers, do the next variable, then do the next variable. On the bottom, we're just going to multiply bottom times bottom. So 3 times 5 is 15. Well, you want to look and see, can this 20 over 15 be reduced? And if it can, then you want to reduce that. That actually divides out to actually just be 16, but we still have x to the 5th, y to the 6th with it. Because 20 divided by 15 is 16. Okay, so we're just going to do a few more. Keeping in mind exactly what our signs are. So on number 5, we're going to have to add here. And so remember how we add. We can only add like terms. So let's multiply these two terms out first. So we've got 3 times negative 2. That's negative 6. X to the 4th times x squared is 4 plus 2. So x to the 6th. Y to the 6th times this y with that imaginary 1 is y to the 7th. Okay, so we've multiplied that term out. Now we're going to add, these next two, we're going to multiply these two together. And so 8 times imaginary 1 is just 8. X cubed times another x cubed is x to the 6th power. And y squared times y to the 5th is 2 plus 5 is 7. Well, notice here we have got x to the 6th, y to the 7th, x to the 6th, y to the 7th. So they are like terms, so we can add them together, because this means we can only add like terms. So negative 6 plus 8, leads us to positive 2. And we still have our variables, x to the 6th, y to the 7th. Think about, you're just saying how many x to the 6th, y to the 7th we have. Okay, number 6, we're going to distribute. So this negative 6t is outside the parentheses, so it needs to be multiplied by everything inside those parentheses. So we're going to say negative 6t times this t squared, plus that negative 6t times the 5t, plus that negative 6t times that negative 9. Remember that sign goes with that number there on the end. All right, so each one. Now, negative 6t times t squared is going to be negative 6t cubed. That's 2 plus imaginary 1. Now, plus this negative 6 times 5 is negative 30 t squared. Last term, negative 6 times negative 9 makes positive 54, and then just the one t, so t. Okay, so remember, again, we're going to distribute this term times each thing that's in the parentheses. So you've got p squared q cubed times that pq. Then minus that p squared q cubed times 2p squared q. Okay, remember, now you can only multiply p's times p's, so p squared times p makes p cubed. Q cubed times q is q to the 4th. So there's that first term multiplied out. Minus, numbers first, we've got the 2. And p squared times p squared is p to the 4th, 2 plus 2. And then q cubed times the q is q to the 4th. Notice now, these are not like terms. This term is a p cubed, q to the 4th, and this one is a p to the 4th, q to the 4th. So they are not like terms, so we cannot join them together. So therefore, that is your final answer. Okay, so we're going to do the same thing again. Negative 3rs times 2r squared s plus that negative 3rs times the 12t plus negative 3rs times that 7. Okay, so we're going to multiply each term out. Here we go with this one. Negative 3 times 2. Use this with a negative 6. R times r squared is r cubed. And s times s is s squared. There's your first term multiplied out. Now, let's work on this one. Negative 3 times 12, negative 36. There is no other r, but we still have to list it. There's an s, we still have to list it, and we also have a t. So all of those have to be listed because they're all being joined together, being multiplied, but you just have to list all those variables separate. So last term here, negative 3 times negative 7 is a positive 21, and we just have the r and the s. So they all have to go in there. It gets sort of long and tedious, but just remember, take one step at a time, take one variable at a time, do your numbers first, then each variable, and you'll be able to get all of that. Okay, so let's look at this. We're going to find the perimeter in the area of this shaded region. Remember, perimeter is when you add up all the sides. Area is when you multiply. You want to know what that shaded part is. Okay, so first we need to make sure this side edge is BC. This side edge is 4BC, which means this side would also be 4BC. This is BC. So we've got to figure out what this side is. If this whole thing is 5, and we've got 1 BC here and 1 BC here, that means we're going to take away 2 of those BCs, leaving us with this would have to be 3 BCs, because this length would be the same as this length plus this length plus this length. So BC plus a 3 BC plus another BC would make that 5 BC. Okay, so following on along, we've got this one. We know what this one is, and this top would also be another BC. So in order to find the perimeter, we're going to add all these up. I'm going to start at the top here and go work my way around. So we've got BC plus another BC plus 4 BC plus 3 BC plus another 4 BC plus another BC, another BC, and 5 BC. Okay, notice that everything is in the form of BC, so we just have to add up how many BCs we have. So here's 1, plus another 1 is 2, plus 4 is 6, plus 3 is 9, plus 4 is 13, plus 1 is 14, plus another one is 15, plus another one is what do I get here? 20 BC. And so remember, if that BC is listed by itself, imaginary 1 in front of all of those. Just trying to check my addition here. So 20 BC. So there's your perimeter. So now area. Okay, we know we can find the area of a rectangle. So what if we find the area of each rectangle? What's the area of this rectangle? Well, we multiply length times width. So 4 BC times 3 BC would leave us with 12B squared C squared. Now let's find the area of this rectangle, and it would be 5 BC times BC, which gives us 5B squared C squared. Now we can add the two areas together leaving us with 17b squared c squared. So there would be your area to break those two shapes down. Okay, and that is it. Hopefully that's not too hard for you guys. You just let me know if you have any questions.